Okay, students, in this class, we are going to speak about an important topic in our plus 2 physics. It is called as projectile motion. Let's understand projectile motion. For understanding projectile motion, let me draw our XY axis. Let this be our X axis and Y axis. Projectile motion, it is a two-dimensional motion. Projectile motion, it is a two-dimensional motion. For speaking about projectile, projectile is any substance which is projected with an initial velocity. Further on, it is moving under the influence of gravity. That is, let us assume that if you are having a substance which is projected with an initial velocity u in this direction, and further on it is moving under the influence of gravity, that substance is called as a projectile. Therefore, the trajectory of this projectile will be in the shape of a parabola and it will fall to the ground like this. Okay. Oh, let me draw it a little bit more appreciable manner. It is falling like this. Okay. Then we have to understand the motion of this projectile. For understanding the motion of projectile, let me define an angle theta. This angle theta, it is the angle made by initial velocity and the horizontal. This angle is called as angle of projection. Angle of projection is the angle in which the substance is projected with an initial velocity. Then let me resolve this initial velocity u into two components as we know about resolution of vectors. We are resolving this initial velocity into two components. This is our ux component and you know it is u cos theta. This is our uy component and we know it is u sin theta. Therefore, the initial velocity is resolved into two components like this. Then this initial velocity is having two components. One is ux, which is called as the horizontal component of velocity, and uy is the vertical component of velocity. Then if we are marking the instantaneous velocities at some points on this projectile motion, let me mark the direction of instantaneous velocity over here. The instantaneous velocity at this particular instant, it will be a tangent drawn like this. And this instantaneous velocity, it will have, let me call it as v, it will have two components like this and one component like this, that is horizontal component and vertical component, in which the horizontal component of velocity, it will be ux itself. It's because in projectile motion, the external force acting over this substance is gravitational force, and that gravitational force is acting vertically downward. Due to the gravitational force, the horizontal component of velocity will not change, but the vertical component of velocity, it will definitely change. Therefore, Vy will be less than that of Uy. And if you are analyzing at the highest point, the instantaneous velocity, it will have a direction in this manner. This should be the instantaneous velocity. And you can see the vertical component of this particular instantaneous velocity is 0, since it is not having any vertical component, and you can clearly understand the horizontal component is instantaneous velocity itself, and that is ux itself. Okay. Then if we are referring a point in the descent of the projectile during the downward journey of the projectile, we could consider a point over here, and the instantaneous velocity will be in this fashion. This is the direction of instantaneous velocity. We could resolve this instantaneous velocity into its corresponding horizontal and vertical component. We could clearly understand the instantaneous velocity in x direction. It will be ux itself, but the instantaneous velocity in y direction will be downward, and it will gradually increase during the descent of projectile. That is, it will be negatively increasing during the descent of projectile. Therefore, if someone is asking you which component of velocity of projectile will not change throughout the journey of projectile, it is horizontal component. Throughout the journey of projectile, the horizontal component of velocity will not change. Throughout the journey of projectile, the vertical component of velocity will change, and the value of vertical component of velocity at the highest point is 0. That all things we have understood from this diagram. Then let's try to formulate the equations regarding the projectile motion. Let's try to formulate the equations regarding the projectile motion. For formulating the equations regarding projectile motion, let's initially say, as I have mentioned, projectile motion is a two-dimensional motion. Therefore, we require both x and y axis to represent the motion. Then, as we know, there are three equations of motion. What are the three equations of motion? First equation is v is equal to u plus at. Second equation is s is equal to ut plus half at square. And the third equation is v square minus u square equal to 2as. We will use these equations intelligently in order to formulate the equations regarding projectile. So, in order to formulate the equations of projectile, since projectile motion is a perfectly two-dimensional motion, we will have to consider two columns. In these two columns, we will write in x direction and in y direction. We will have to find out separately x direction and y direction. Let's say, what is the initial velocity in x direction? From the figure, it's clear that initial velocity in x direction is u cos theta. What is the initial velocity in y direction? The initial velocity in y direction is u sin theta. Okay, so now we know what is ux and uy. Then we can say the acceleration in x direction in this situation, it is 0. It is because the velocity in x direction is not changing, or it is a constant throughout the motion. Since the velocity in x direction is constant, the acceleration in x direction is 0. Then what about the acceleration in y direction? If we are considering the ascent of the projectile, that is the upward journey of the projectile, the acceleration in the ascent of the projectile is minus g. It's because velocity is decreasing. Okay, that's the reason why I'm taking minus g. Okay, then let's find out the final velocity in x direction. In order to find out the final velocity in x direction, we can use the first equation of motion. If you are using the first equation of motion in x direction, we could write Vx is equal to ux, Vx is equal to ux plus axt. I could write Vx is equal to ux plus axt. This is the first equation of motion in x direction. In the similar manner, the first equation can be used in the y direction as Vy is equal to ui plus ayt. Okay, then let's substitute for the values. Vx will be, what is ux? Ux is u cos theta. What is ax? Ax value is 0, therefore no need of writing plus axt, that is 0. Therefore, Vx is equal to u cos theta. In the similar manner, if I am substituting for Vy, we will get Vy is equal to u sin theta. The value of Ay is minus g, therefore u sin theta minus gt. This is the equation for velocity in y direction. Now we are having the final velocity in x direction and the final velocity in y direction. Now we are having two equations, final velocity in x direction and final velocity in y direction. Okay, then let's find out the position of a substance at a time t. If we have to find out the position of a substance at a time t, then you will use the second equation of motion. The second equation of motion is S is equal to ut plus half a t square. And if I am using the second equation of motion in x direction, I will write x is equal to uxt plus half ax t square. X is equal to uxt plus half ax t square will be the x position of the projectile at a time t. In the similar manner, the y position, the y coordinate of the substance at a time t, it will be y is equal to uyt plus half ay t square. Okay, then let's substitute for the values of ux and ax. Then you will get x is equal to ux is u cos theta, therefore u cos theta t. Ax is 0, therefore you could write it as such, that is x is equal to u cos theta t is the x position of the projectile or the x coordinate of the projectile after a time t. Then we can substitute the value of uy and ay so that we could obtain the value of y. It will be uy is u sin theta t, ay is minus g, therefore it is minus half g t square. Therefore now we are having the x coordinate and y coordinate of the projectile at a time t. Then after finding out the x coordinate and y coordinate, let's find out the time of maximum height. We are going to find out the time of maximum height. Time of maximum height is denoted as Tm. It is the time taken for the projectile to move from here to here. That is the time taken by the projectile to reach its maximum height. For saying the time of maximum height, let's define this coordinate as x is equal to 0, y is equal to 0 point. This point is x is equal to 0, y is equal to 0 point. This point will be at maximum height. Time of maximum height means this point will be at maximum height, and this height we are denoting it as h. H is the maximum height attained by the projectile, therefore the y distance at this point is h. Then we are defining the maximum horizontal distance as r. This is the maximum horizontal distance, it is r. This is h, therefore at this point the coordinates will be, the x coordinate will be half of r, that is r by 2, and the y coordinate will be, x coordinate will be r by 2 and the corresponding y coordinate it will be h. This point is r by 2 h point, In the similar manner, this point's coordinate will be, the y value of this particular point is 0, the x values are, therefore it is r comma 0 point. Okay, we are defining 3 points. Then let's find out the expression for time of maximum height. For that, what is time of maximum height? It is the time taken by the projectile to reach its maximum value. I can see from this diagram the y value of this particular point, it